Hi there. We're going to do inequalities, and these next two sections deal with inequalities. This section here is inequalities on a number line, and our next section will be inequalities on a coordinate system. And you'll know the difference because they'll either give you a number line or a Cartesian coordinate system. Well, before we start inequalities, we're going to practice solving equations, which is something that you need to know. So to begin with, we'll start practicing, and I have some examples here. So when you do want to solve an equation, ultimately you want the x by itself. These aren't going to have the y's in them. You're not going to have the two variables until the next section. So here we'll have one variable that we want by itself in this section. Well, to begin with, on the left-hand side, you can simplify before you start to move. On the right-hand side here, there's some things you can do before you start to move things. So over here, and if it helps, go ahead and draw that line. Over here on the left, I'm going to take like terms and combine those like terms. 6x and 1x is 7x. The 2 stays by itself, equals, maybe I better move it over a little bit so it's closer to the equal sign. That way I can keep my line there. We have 7x plus 2 equals, that's all we can do on the left-hand side. So again, simplify your sides before we start to move. On the other side, we have 5 subtract 10, or 5 plus a negative 10. Either way, we know that we'll have a negative 5 when we add those together. These 5 positives will take care of those 5 negatives, and you'll be left with 5 negatives. All right, the sides are simplified, it's time to move. So we ultimately want this variable by itself. We have to get rid of two things, the 2 and the 7. Get rid of what's being added or subtracted first by adding or subtracting the opposite. So here we'll have, or adding the opposite. So we're going to be adding the opposite. I think you knew what I meant. So we have 7x by itself here, and then negative 5 and a negative 2 is a negative 7. Now we got rid of what's being added. Now right here, this is a multiplication. And it's a whole number. Otherwise, if it were a fraction, I'd multiply by the reciprocal. But here it's just a 7, so I'll divide by 7. Now, again, this sign will always match because we want it to be a positive one. So we don't have the opposite here, because if you do put a negative in division, your answer would be negative. So we want to keep it positive. So these cancel out. So you're left with a positive 1. Negative 7 divided by 7. Well, remember the negative and positive rules. This is a great review for the final. We have, whenever you have one negative, which is odd. If you have an odd number of negatives, your answer is negative. So your answer is a negative 1. And you can put that back up into the original and check it. We're just going to keep moving on. So x equals a negative 1. Let's try the next one. Again, we simplify by combining like terms before we start to move things to get that x by itself. It's nice there's nothing to do on the right-hand side of the equal sign. Okay, that there's just 0. So what we'll do is we're going to take the 8x and subtract the 7x. Those are like terms, which gives us a 1x. The subtract 5 is by itself equals 0. Again, I'm not going to erase it, we'll leave it. Here we've simplified. Now all we have to do is get the x by itself. So we're going to get rid of the subtract 5 by adding 5. Minus 5 and a positive 5 is 0. The x is now all by itself. 0 plus 5 is 5. So your answer is 5 here. And again, we don't have another step. We don't have that second step of division or whatever we needed to do because the x's already has the 1 in front of it. So you're done. Okay, let's try another one. And then we'll apply it with some inequalities. Move this up a bit. Okay, now what we'll do here is we have to simplify this left-hand side. There's some like terms that we can combine. Over here on the right-hand side, there aren't too many like terms. There aren't any like terms. These two will have to stay separate. So we're going to use the distributive property first. Get rid of those parentheses using the distributive property. 3 times 2 is 6y plus 3 times a positive 1 is a positive 3. So get rid of your parentheses. Now combine like terms, which gives us 6y and the 4y. Those are the like terms. We'll combine those and get 10y. Plus the 3 stays separate. Over here we have 10 minus y. All right, so our sides are simplified. We need to start to move. And notice that I have y's on both sides. I have a y on the left, I have 10 of them, and I have a minus 1y over here. Because we're going to be doing inequalities, and with inequalities, we need the variable on the left, just so that the graph makes sense when we graph our answers. So I suggest that you practice taking any variable over here and moving it to the other side. Well, what does that entail when you move it to the other side? Well, it means get rid of it here. So that means you would add a positive y, positive 1y, and you add it to the other side because you have to keep it balanced. So by getting rid of it here, you're actually putting it over here, just so that you stay balanced, you know, with your, think of it like a teeter-totter. So that's gone. So we now have 11 y's on the left, and we have no y's on the right-hand side. So you'll need to get your variables over to the left by getting rid of them, adding the opposite. If that had been a minus 2y, I would have had a plus 2y to both sides. All right, so just add the opposite. Okay, now we're back to the other two where we have these, we have to get rid of the 3 and the 11 to leave the y by itself. I'll get rid of what's being added or subtracted first by the opposite. So we'll adding the opposite, negative 3 to both sides. These are just 2 steps. When you get to this point, generally it'll be just a 2-step solution. Those are gone. So we have 11y equals, oh, that's all right. It's not going to be a whole number, but that's fine. 10 and a negative 3 is 7. Oh, let me get rid of that. Sorry. There. Now, to get the y by itself, I'll divide by 11. It does create a fraction for an answer, and all you need to do is ask yourself, can that fraction be reduced? And if not, then that's your answer, 7/11. If they want a fraction, you know, I doubt they'll want a mixed number. In algebra, we don't generally deal with mixed numbers. You'll just leave it as a fraction, and that can't be reduced, so there's your answer. So that was just kind of a general review of solving an equation. So what we're going to do now is we're going to look at some inequalities and solving some inequalities. All right, so let's talk about some inequalities. Well, first off, I know that if I'm given an equal sign, okay, we're just solving in the number system. We're not on our Cartesian coordinate system where we've got the different quadrants. So we've kind of reverted back to just finding one number that would work in here. Well, here, you know, to solve this, we would subtract 1. So, or just even look at it to know that x has to equal 4. That's our only answer. X equals 4. X can't be 2 because 2 plus 1 is 3. It's not 5. So when you have this equal and you're solving the equation, there's only one solution. and its x equals 4. Well, what we're going to do now is we're going to apply some inequalities. And an inequality changes things a bit. So we have more than one answer now because, here we just had one, x can be 4, solving this equation. But what happens if I were to put in 0 here? Could x equal 0? 0 plus 1 is less than 5 because 1 is less than 5. So 0 is an answer. Could x equal 2? Is 2 plus 1 less than 5? Sure. What about 3? Okay. Is 3 plus 1 less than 5? Sure. I could even put some negatives. A negative 10 plus 1 is a negative 9. And a negative 9 is less than 5. So we have more than one answer here. We have an infinite number of answers. So that's what we're going to look at, is how to solve it, and then how to display it graphically, our solution, on a number line. This is just on a number line. And then we're also going to introduce what's called interval notation. And interval notation is something that my math lab really likes, and I want you to be used to it for your next classes. Okay, when you solve this, it's just like solving this, except one exception. But you can treat this inequality like a glorified equal sign. So you would, you can add the opposite. The only thing is that if you divide by or multiply by a negative, you have to flip this over. And so we'll do some examples of that. Otherwise, it's an equal sign. Whatever you do to one side, you do to the other side. You just need to remember that if you ever have to get rid of a negative in front of this x, by dividing or multiplying, you'll flip this over and make this a greater than. Okay. Now here, we're going to solve this. We're going to subtract 1, just as if it were an equal sign. So don't let that, bother you, the fact that it looks different. It's just an equal sign. X is less than, that's how that's read, less than the smaller end, 4. What this means is that any number less than 4 will work in this equation, is what it's saying. Now, and again, I just, we subtracted 1 to solve it. And the only time this is not really treated like an equal is if you divide or multiply by a negative. So we have all x's less than 4. Okay, so we've solved that, but we haven't displayed the solution graphically yet. I mainly want to talk about these right here. This one's slightly different, and it has that bar underneath. And what that bar means, if we were to solve it, just like we did the last one, subtracting 1, just this means that 4 could be a solution here. 4 is included in the solution. So the x's are less than 4, or the x's are equal to 4. So it's read x's are less than or equal to 4. This one does not include the 4 as a solution. This one includes the 4. So that's what that bar means. Are you including this number or not including this number? Okay. The same way with greater than. Maybe we want our x, whatever it happens to be, add 1 and have it greater than 5, rather than less. We don't, here we want the x's smaller than this 4. Solving this, we have x's greater than is how that's read, 4. So anything greater than 4 will work here, like 5, which is greater than 4. 5 plus 1 is 6, which is bigger than 5. Or 7, because 7 is bigger than 4. 7 plus 1 is 8, which is bigger than 5. So that opened end points towards the larger number. Here, again, we should be getting used to solving this beast. The difference between these two is that this one would include the 4 as a solution, whereas this one would not include the 4 as a solution. Well, how do you graph these? How do you represent the solution on a number line rather than using what this is called set notation? My math lab, here I'm gonna, set notation would be the set of all x's such that x is less than 4. Okay. That's one way to display the answer. You're going to have all these x's such that x is less than 4. And these would be just choices. You're not going to have to write that on your own. It would just be a choice. Graphically, how would you do this graphically? Well, I'm going to draw a number line here, and we're going to represent this on a number line. And again, these are just one variable. I didn't draw it very big. 1, 2, 3, 4, 5. There's our 4. All right. So here, you're going to go to the 4. Now, some of you may have used like an open circle, but my math lab doesn't do that. My math lab says, okay, if it doesn't include it, you use a parentheses on that point. If it does include the value you're looking at, you use a bracket, okay? And you have those parentheses and those brackets on your keyboard. So here we want x's that are smaller than 4. Well, you go to the 4 and you use a parentheses because you don't have the bar underneath. And the nice thing is that if the x is on the left, this inequality tells you which way the arrow goes. But we want x's smaller than 4, which go in this direction, okay? So this would be the set notation, and this is the graphical notation. We're going to practice the graphical notation, then we're going to come back and look at interval notation for an answer. There's 3 ways you can write the answer. So maybe it's not so much solving it, it's how do you write the answer. We have the set notation, we have a graphical. So let's look at this one graphically. What would this one look like? Yeah, I can. And I'm trying to use the blue because my math lab uses blue for this. So we have 0, 1, 2, 3, 4, 1, 2, 3, -4. All right. So we're going to go to our 4. And it's going to be a bracket, and the bracket's going to face in the direction your arrow is going. So you'll notice on your keyboard, you have this bracket, and then you also have this bracket, and it faces the direction of your arrow. I want x's that are smaller than 4. Numbers smaller occur to the left. So because of that bar, rather than using the parentheses, I'm going to use a bracket on the 4. And then my arrow will go to the left. And that's displaying these 2 graphically. One includes the 4 and numbers less than. One includes the 4, sorry, and less than, and one doesn't include the 4 and is less than. All right. Okay, now we're going to talk about with these 2 interval notations. Since I've got them here, I'm going to go ahead and talk about them. Interval notation it's very useful. And unfortunately, though, at times it can look just like an ordered pair. But interval notation uses these, all right? And what it does is that the best way for you to do interval notation is to look at the graph. Now, this graph is going to the left forever. And if it's going to the left forever, out here, this is a negative infinity, all right? So it's going to a negative infinity. And negative infinity just means the smallest negative number you could ever think of. It's not really a certain number itself. I mean, infinity is not a number. It's a concept. It's an idea of going this direction forever. That's what that means. So here, interval notation, we're going to start actually from a negative infinity is the furthest to the left. This first number is always furthest to the left. And the next number is where you would stop on the right. which would be a 4. So it kind of looks like an ordered pair, but it's interval notation. And what it means is you can pick anything between a negative infinity and 4, but not including 4. And you never include a negative infinity or a positive infinity. And we'll practice this idea. I just wanted to introduce it to you so that when you see it next semester, it's not quite so new and confusing. Okay, this one. Well, the furthest to the left we're going to go is negative infinity. Okay. Whenever your arrow goes to the left, it's always a negative infinity. And we're going to stop here on the right at 4, but we're going to include the 4. So these match always. Those always match. All right. So here we have, and then I could write the set notation for this one, such that the set of all x's such that x is less than or equal to 4. So we have the set notation solution, the graph solution. These will be multiple choice, by the way, this graph. And then you'll have to write your graph as an interval notation. This means your answer is found between a negative infinity and 4. Here, your answer is found between a negative infinity and 4, including the 4. Okay. Let's look at our other greater thans and see, and we'll practice this. Okay. Here, let's graph both of these, and then we'll write them in interval notation. Here, so graph this one, graph this solution. There's our arrows. We have 0, 1, 2, 3, 4. Okay, and then here we have 0, 1, 2, 3, 4. And obviously we could just keep going. Okay, on both sides. All right, so let's go ahead and let's graph this first one. First off, we want x's that are larger than 4, but not including the 4. So we do go to the 4. You just go to this number. You're going to have to determine whether or not you're going to have, a parentheses, or you're going to have a bracket. Which direction will the parentheses face? Well, we know it's a parentheses because there's no bar. And we know we're going to be going to the right because we want numbers that are bigger than 4. So at the 4, our parentheses is going to face the right. And our arrow always goes in the same direction if your x is on the left, but we want x's bigger than our 4. And that's the graph. That would be the graph of the solution. And they might extend their number line a little bit this direction. Here, we're going to go to the 4, but is it going to be a bracket or is it a parentheses? And what direction will it be facing? Well, we go to the 4 because of the bar, this equal, it will be a bracket. And we know we want x's bigger, so we're going to be going to the right. So our bracket has to face the right. And then we want x is larger than the 4, and numbers larger always occur to the right of that number. Okay. So that's the graph solution. How do we write the interval notation solution? Well, here you always go to where you're starting. On the other ones, we were starting at a negative infinity. And here we're going to start, our furthest to the left is the 4. And it's a parenthesis, so that will match. That means it's the 4 is not included. And we're going to go to the right forever. And forever in math is represented with infinity. So this means we're going to go from 4 to infinity. Any answer between 4 and infinity will work, not including the 4. So we have a positive infinity going in this direction. A negative infinity, this one was a negative infinity before, because it was going to the left. is a negative infinity. Going to the right is a positive infinity. The infinity symbol will show up in the bottom of your MyMathLab. That symbol will show up for you to click on. And so will these inequality symbols as well. Okay, what about this one? Well, this one starts. So it's really important to remember that in interval notation, this is the smallest number in your solution. And the smallest number, we're not over here. So the smallest we've got is 4, including the 4. And the largest we'll ever go to is infinity. And infinities never have a bracket. MyMathLab won't accept that. It's always a parentheses because it's not a specific number. This bracket means a specific number. So this is not, it's just an idea of getting bigger and bigger forever. All right, now let's practice these 3 ideas because though that's the main thing for this section. And I have some written out here. Start with this one. So we're going to solve it. We're going to write it in set notation. We're going to graph it. And then we're going to do the interval notation after we graph. It's just easier to look at the interval notation from a graph. Okay, let's solve it. Simplify the sides. Again, this is just an equal sign here. Think of it as an equal sign unless you're getting rid of a negative here. Then you'll have to flip it. So here we'll go ahead and subtract 3 because you can't simplify. There's no like terms on either side. We'll go -3, -3. So we're solving the equation. We're getting the x by itself on the left. So 8x is less than or equal to -24. Perfect. Divide by a positive so you will not flip this over. And it does matter the direction. This direction does matter with your solutions. Is your arrow going to the left or to the right? Do you want numbers larger or smaller? So that is important, which means it will stay because we divided by a positive. We now have our x. We have a 1x less than or equal to, and that's a -3. Notice that here I was adding a negative. You do not flip the inequality. Not when you're adding a negative, only if you were to divide by a negative would you flip that inequality. Well, we're going to graph this now, and MyMathLab would write your set notation as the set of all x's such that x is less than or equal to a -3. We're going to graph it. Well, we know we're going to be going to the -3. We have to decide, do we want a bracket or a parentheses, and what direction the bracket or the parentheses will be going. We'll go to the -3, and we know that our arrow is going to be going to the left because we want x's that are smaller than the -3 or equal to it. Our bracket then will be going in that direction because that's the way our arrow is going to be going. These numbers are smaller than a -3, so our arrow is going to be going in this direction. There's our graphical solution. We have our set solution, graphical solution. Let's look at the interval solution. Our interval solution, the furthest to the left, the number that would be the furthest to the left, well, this is going on to the left for forever, and that's how we represent negative infinity. A number that's to the furthest to the left that you could ever have, goes on forever to the left, is a negative infinity. And it's going to stop. So we're going to start at a negative infinity, and we're going to come to this number and stop, -3. But we're going to include that -3. So again, those two match. The bracket. If you have a bracket, you'll have a bracket in your interval notation. That's why sometimes it's easier to graph the solution before you come up with this, until you get used to it. So the set notation, the graphical, and the interval notation. Interval notation. Solution. All right, and again, the key here is that the first number in interval notation is always the smallest number. Negative infinity, if you have a negative infinity, it will always come first. you can't be smaller than a negative infinity. And then this one will be the larger one to the right. Okay, let's look at another one. Keep practicing quite a few of these. Again, there's no simplifying that has to do on the left. You've combined like terms, nothing you can do. The right side, the 6, nothing we can do. So we're going to start to move things. So we'll get rid of what's being added or subtracted first. Again, we will not flip the inequality because we're not dividing by a negative. We're adding a negative. So 5x is greater than or equal to 5. I try to keep these nice numbers. So now we'll divide by 5. Awesome. Which means we have x greater than or equal to 1. Our set notation would be the set of all x's such that you pick an x so that it's greater than or equal to 1. There's that solution. Let's do a graphical solution. Let's look at this and do a graph. Well, we're going to go to the 1. We know we're going to either be putting a parentheses on the 1 or a bracket on the 1, but we have to know what direction to put that bracket, because brackets can go this way or brackets can go that way. Same with parentheses. Well, we know our x's need to be bigger than 1, so we're going to be going to the right of the 1. Our bracket then needs to go to the right. And our arrow represents the numbers that are larger than 1 or equal to 1. There's your graphical solution. Interval notation will go, we start, the 1 is going to be the smallest solution you can have. You can't have anything smaller than a 1. Nothing over here will work in that equation. It has to be over here. So we start with the 1, and it looks like we'll be going in this direction forever. So to the right forever is a positive infinity with a parentheses always for infinity. All right, and there, set notation solution, graphical solution, interval notation solution. This just means all numbers between 1 and infinity will work, and you can include the 1 in your solution because of the bracket. All right, let's do another one. No, it kind of comes through. Oh, well. All right, let's solve this one here. Again, there's no simplifying, and we're going to practice somewhere. We're going to have to do some like terms and things like that on the left and right, and then start to move stuff. We'll make them more difficult. I mainly wanted you to get used to graphing and then the interval notation. Again, nothing to simplify on the left, nothing to simplify on the right. And this is just kind of like a glorified equal sign. So we're going to subtract 1 on both sides, just like as if it were an equal sign. Negative 4x is greater than 8. And I did not leave a lot of room for the solution before we hit. I'll go ahead and rewrite it up here. Don't want to be crowded. To get rid of the negative 4, I do have to divide by a negative 4. So this is kind of what I've been talking about. If you divide by a negative or multiply by a negative, we probably won't be multiplying by negatives in this class. That'll come later in your other classes. Here, I have to have a positive 1, so I have to divide by a negative, because a negative over a negative is a positive. Those cancel. I do have my x, but don't forget you flip that inequality when you divide by a negative. Not when you add a negative. It doesn't flip. It's only when you divide by this negative that you flip it. And this gives me a negative 2. 8 divided by a negative 4 is a negative 2. This affects where we find our solution. So rather than finding them to the right of the negative 2, we need to find them to the left, smaller than the negative 2. We have the set of all x's such that all x's have to be less than a -2. Now let's graph it. We're going to go to the -2. On the -2, we're going to either do a parentheses or a bracket. Because there's no equal sign, we'll do a parentheses. What direction will the parentheses face? To the right or to the left? That's what you need to decide. Well, because our answers are going to be to the left because they're less than, our parentheses will face that direction. So we'll go to our -2, and the parentheses will face that direction. That's also the direction of our arrow. The arrow represents solutions. Anything over here will work in that equation, any number. So we have the set solution, the graphical solution, and from this, it's really easy to come up with the interval notation or the solution written in interval notation. The furthest to the left this is going to go is a -infinity. That's to the left forever. To the left forever would be a -infinity. And then it will stop eventually at the -2, but not include the -2. This interval notation, unfortunately, does look like an ordered pair, but it's not. You'll know the type of problem you're solving. This is the interval notation. So the answer is written in interval notation. I was trying to write or think. Notation. Okay, so interval notation. This means that your answers are found between a -infinity and a -2, like a -3, -4, -5, -6, all of those, but not including the -2 because of the parentheses there. And of course, you can never include a -infinity because it's not a number. It's just an idea of getting less and less. Okay, let's do another one. Here on this one, again, there's no simplifying that needs to be done. On the left, as far as combining like terms, or on the right, what we'll now do is concentrate on getting the x by itself. In this example, we don't have to add the opposite of anything because you're not adding or subtracting anything to the x. All we have to get rid of is the -3. In order to get rid of the -3, we're going to divide by a -3. And you'll just need to remember this is the only time it's not treated like an equal sign. Otherwise, it's just an equal sign as you're solving it. X, because I'm dividing by a negative, I'm going to flip this inequality. -9 divided by a -3 is a +3. So my solution is all x's that are larger than or equal to 3. The set of all x's such that x is greater than or equal to 3. Graphically, what does this look like? This solution, you'll go to the 3. Because of the equal sign, it's going to be a bracket. And we want x's that are larger than 3. So let's see, 1, 2, 3. So because we want them larger, our bracket's going to face in the larger direction. And we'll have our arrow go along here as well. So we need, our solution is found in this area here, whether you can put 5 in here. -3 times 5 is a -15, which is less than a -9. So any number over here will work. Set notation solution, graphical solution. Now let's write the solution in interval notation. And interval notation, really, if you think about it, is a little bit easier to write than this one. We start, so the first number in interval notation is the furthest to the left, which is 1, 2, 3. That'll always match. That means it includes it because of that bar. This, and this bar all mean the same thing. It means included. So we're going to start at 3 and we're going to go in this direction forever. And that's how we write forever, is infinity. It's going to keep getting larger and larger. And that would be the interval notation of the solution. Anything between 3 and infinity will work. And or 3 itself will work because of that bar. Perfect. All right, I hope that didn't, that's all right. We'll just kind of ignore it, that little bar thing there. Oh, well. All right, let's go ahead and solve this one. Well, this one's going to require a few more steps to solve because, there's nothing we can do here because those are not like. There's nothing we can do here, but I do have R's on both sides. So my recommendation to you is to move this over to here just because of the inequality. It's easier to read, which means I'm going to subtract 3R to get rid of it here. 4R and a negative 3R is 1R. And I'm left with the negative 1 over there. So I'm hoping that that step wasn't too difficult. Again, just to get rid of it here by adding the opposite, which moves it over to here. Now, to get the R by itself, because we have R's on the left only, we'll subtract 2. Or add a negative 2, same idea. R is greater than or equal to, we don't flip the inequality, we never divided by a negative or multiplied by a negative, negative 3. All right, so there's my solution. I can write it in set notation, the set of all R's such that R is greater than or equal to a negative 3. Kind of get it in there before I hit my other marker. Now, graphical. I know I'm going to go to the negative 3. Okay, I know I'm going to go there. And it's an equal, so I'm going to use a bracket. I want R's that are bigger than the negative 3. Negative 1, negative 2, negative 3. And those are going to be to the right. And again, an easy way to think about it is that points in the direction of your arrow, as long as the variable's on the left. I want R's greater than a negative 3, which means that they're going to go here. And this is just the beginnings because, there are times when you're solving where it'll stop. It won't go on forever. There are some equations where it'll stop and you'll have between, just two numbers. It's not always going to be infinity, but for our purposes, it'll be infinity. Right. Now, how do you write this in interval notation? Well, the furthest to the left is a negative 3, and we're going to include it. And the furthest to the right, it goes on forever, and infinity is our symbol for forever. So there's your interval notation solution. Great. What we're going to do now is we're going to look at maybe one of these or so from your homework and kind of what does the homework look like. Let's look at number 12 on your homework. I believe this might be the last one. This one doesn't have too many homework problems on it. Got to do some simplifying. We've practiced it already today. We'll practice it again. We're going to simplify. And you see on your homework, you're going to have choices, multiple choice. It'll just be a multiple choice. You'll have a bracket. You'll have, a choice of parentheses. Is it going to the left, to the right? And then they'll want you to write the interval notation, the answer in interval notation. All right, but let's go ahead and solve this one, and this will be the last one we do. We've got 3x plus 4 minus 4x less than or equal to 4, 3x plus 1. Oh, we got some things to do here before we start moving things from the side to the side, but it's not too bad. Let's look at our left-hand side of our inequality. So we're just going to kind of look over here, simplify this, use the distributive property, not too bad. 3 times everything in here, which gives us 3x plus 12 minus the 4x. that 4x is not in the parentheses, which means you will not take it times the 3. It's only what's in the parentheses do you multiply with the 3. It's outside, so you don't multiply it with that. Only what's inside gets multiplied. Let's go ahead and look at our similar terms or like terms, and we've got a couple x's here. So we have a 3 and a minus 4x, which gives us, when we combine those, a minus 1x, or just a minus x, plus 12. Wow, so we're done on the left. That's all we can do. Let's move to the right and kind of go through the same idea. We've got to take that 4 times what's in the parentheses, 12x plus 4. I multiplied those to the 4, subtract the 9. The 9's outside the parentheses, so you don't multiply it to the 4. We'll combine like terms now. The only ones that are like, it looks like, at the 4 and the minus 9. Excuse me. So we've got 12x and 4 minus 9 or plus a negative 9 is a minus 5. And we still have our less than or equal. We haven't done anything like that. I'm going to go ahead and kind of plus 12 is less than or equal to 12. Now I'm going to go ahead and I'm going to move the 12x to the left because of the inequality. Otherwise, you'll have to flip it. And when you flip it, you have to be careful about the inequality. So I'm going to go ahead and move this over. So I want the only x's. I only want the x's on the left. So I want to get rid of this whole thing by adding the opposite. I don't want to separate them. That's a division that would separate them. I want to move the whole thing. I want to get rid of the whole thing by adding the opposite, which means I have a minus 13x. Really? Oh, I copied it down wrong. That's an x, because I'm thinking, oh, we're going to get a fraction. So we're not too far off to back up. And this is our last problem, and nothing in me wants to redo the video. So I caught it. I'm thinking, the answer is a fraction. We don't want a fraction on a number line. So we don't have to back up. You guys are probably saying, oh no, she wrote it down wrong. We're back up to here because I forgot that x on the 9. Which means when we multiply this through, great, but rather than combine the 4 and the 9, I have to combine the 12 and the 9 minus 9x, which is 3x. All right. So again, when I copied it down. I don't think I copied anything else down around. And that gives us 3x plus 4. So I had to combine those two rather than those two, which means, well, that's okay. Yeah, that one's right. So I'm going to bring down a 3x plus 4. Now we'll start again. Sorry about that. It wasn't too bad. Subtract 3x because I want the x's on the left. So I'm going to get rid of them on the right, adding the opposite, minus 3x. So these are gone, minus 4x plus 12 less than or equal to 4. When you get to this point, it's 2 steps. We'll get rid of what's being added, the 12, and then we'll get rid of that minus 4. Again, we'll subtract 12. We're working on getting that x by itself. Negative 12 and 4 is going to be a minus 8. This is better. Now I know that we're on the right track since we're getting a whole number answer. To get rid of the minus 4, we'll divide by a negative 4. And because we're dividing by a negative, we will flip the inequality. -8 divided by a -4 is a +2. Our solution then, okay, this is the set notation. You could put the set of all x's such that x is greater than or equal to 2. But graphically, we're going to graph it and then we'll look for the answer. Graphically, quickly sketching a graph. We're going to go to the 2. We're going to have a bracket, and the bracket's going to face to the right because we had to flip it here on this step. And we want x's larger, so it will go in that direction. I can do it in blue. All right. Now looking at this, these solutions here, sorry. Maybe I can put them on the side by side here. We have a bracket. The bracket eliminates B and D. Can't have B and D. Those are parentheses, not brackets. We want to go to the 2 and go to the right of 2. This one's going 1, 2, 3. This one's on the 3. This one's on the 1. This one's going to the left, which means F is our only choice. That's a 2 right there, and it's going to the right. How do you write this in interval notation for this answer up here? We start here at the 2, and we go to the right forever, which is, I must have hit something. So that would be your interval notation from 2 to infinity. All right, well, I'm hoping that you have somewhat of a kind of an idea of how to find the solution, graph the solution, and write the solution in interval notation. And if not, you'll need to contact me. All right, thank you. Bye-bye.